Today I wanted to take a second to demonstrate why exactly the power rule works the way it does. We're going to start by looking at this square, and we're going to decide to label the length of each side with the variable x. This means we can calculate the area of this square by doing its length times its width, or x squared. And we're going to choose to label the area of this square with the variable y. Now we're going to do something that is the bread and butter of differential calculus, and we're going to see what happens when we change x by some really tiny amount. We're going to increase our side lengths by some infinitely tiny change to x that we'll label as dx. In doing so, we've also changed our total area y by some infinitely tiny amount, which we'll label as dy. If you want to calculate this change to our area, dy, all we have to do is find the areas of our new indigo and purple rectangles using their bases times their heights. And it's important to remember that the widths of these rectangles, dx, is actually infinitely tiny, so these indigo rectangles really almost function as little tiny line segments, and as such, our purple rectangle really has no calculable area. This means that to find the real value of dy, all we have to do is find the length times the width of our indigo rectangles. So dy equals x times dx plus x times dx. And if we combine like terms, dy equals 2 times x dx. Now, all we have to do is divide both sides by dx, and we get that if y equals x squared, then dy over dx equals 2x.